Okay, so our next lesson, still in the multiplicative reasoning chapter, is going to be called direct proportion. Now, I've been back through and I don't think we've done this. You might have seen it before, but it's really important. Really, really important. I'm going to be saying the word fish a lot. We'd have a good laugh actually about this, I think, in lessons, so feel free to laugh along. So, direct proportion. So, we would say that two variables are in direct proportion if, as one goes up, the other goes up. More specifically, if one were to double, the other would double, for simple cases of direct proportion. We know that two variables are in a direct proportion relationship if their graph looks like this. So this is just kind of an aside. This is a common question. Two variables would be said to be in direct proportion if their graph was a straight line through the origin. So that's how we would know by looking at a graph if two things were in what we call direct proportion. That isn't overly important for today, but that is a really common exam question. You can look at a graph and all you need to say was straight line through the origin. But anyway, let's have a look at what this means in terms of what we're doing. So we're going to be told that a couple of variables, by variables I just mean letters, so a couple of letters are in direct proportion. From that information, we will be able to make a formula which we would then be able to use. And it's going to involve a symbol that we're going to call a fish, and you're going to just follow this template and you're going to be able to get it right every time. Some of these questions get really tricky, but if you stick to the template, you won't go wrong. So let's have a look. So let us say that x is directly proportional to y. When x is 10, y is 5. Find an equation connecting x and y. So that's kind of the waffle that we would get at the start of one of these questions. Our job is going to be to unpick this waffle line by line and translate it from words into maths. So as always, mathematicians, lazy, we've got a symbol for directly proportional. So go along in order. So we've got x. Now for directly proportional, we're going to use a fish. Okay? So we've got x. Now in a lesson I would be saying x, fishy, y. Now this isn't technical. If you were going to read this out to somebody that wasn't me, you would say x is directly proportional to y. In a lesson, we're going to be saying x, fishy, y. That translates that first line into maths. Now, see, I sound a bit silly saying this on video, but this is exactly what I would be saying to you in a lesson. We're going to go to the fish market, and irrespective of what type of proportion we're dealing with, at the fish market, you will always be able to trade your fish for an equals and a k. So we trade in our fish and we write equals k. Okay, so I'm just going to write trade that for equals k. Now we will always be able to do that, even when we do what we call inverse proportion. This trade is still going to be a thing. So we trade our fish for an equals and a k. Now you're going to be thinking you're too cool to go to fish markets. Trust me, if you follow this template, you'll get it right every time. So x, fishy, y. Now this k has a name. This k is called the constant of proportionality. You don't have to say it like that. It's called the constant of proportionality. Okay, so we always use k. It's like y equals nx plus c. We always use n, we always use c. In this case, we're always going to be using k, and it's going to stand for constant of proportionality. Okay, now our next job is to find out what k is. you're probably writing yourself some little steps or something as I'm talking, you can actually shut me up and pause me if you need to, which is ideal. Right, so we're now going to work out what k is. So whenever I see an x, I'm going to put a 10 equals k. Whenever I see a y, I'm going to put a 5, and I am going to now write that times sign. The secret times sign that was lurking in there, I'm now going to write it. So now we need to work out what k is. Well, now k times 5 is 10. So if you want to do bubbles, some of you diligently do bubbles like me, I'm going to divide both sides by 5. So I get 2 equals k. Your equation, therefore, is your second line rewritten, but now we know what k is. So our answer would be x equals 2y. Now that is the answer to find an equation connecting x and y. Well, there's our equation connecting x and y. Now sometimes you'd be asked to use that equation. So it might say, find x when y equals 100. Something like that. That means now you've got an equation, use it. So I would say that x equals 2y, which is 2 times 100, so x equals 200. Okay, now we're going to do a couple of these because I would do a few in the lesson. People tend to just take a couple to be convinced that we do need to go to the fish market and we do need to do all of these steps. In a mark scheme, you're probably looking at 1 mark for those lines, 1 mark for the working and 1 mark for the answer. And this will come up in your GCSE, some form of proportion, either direct or inverse. So this week we're going to look at direct and inverse, and we're going to really, really get that sorted. We might even let inverse kind of spill over onto next week a little bit. We just need to make sure we've got this sorted. Right, I'm going to do another one. So, this is the end of that question. So, let's say m is directly proportional to q. Find q when m equals 10, given that m equals 9 when q equals 3. So it looks a little bit different to the last one. So m is directly proportional to q. Find q when m equals 10, given that m equals 9 when q equals 3. Right, I want you to not get overwhelmed at the start of a question. You're going to pick it out line by line. So first line, m. Directly proportional, fishy, q. You can almost now get rid of that. We've dealt with that now. Yeah, we've done m is directly proportional to q. Find q. Well, we can't do that yet, but we're going to use given. But before we do that, we need to go to the fish market. Trade in your fish for an equals and a k. It says, given that m equals 9 when q equals 3. m equals 9 when q equals 3. You're always looking for a pair of numbers that you can use to work out k. There's our pair that we can stick in to work out k. I couldn't have used that pair because I don't have a pair. I've only got one number here and I don't know what q is. That's going to be my last step. That's like this bit here. Okay? So you look for a pair that you can put in to work out q. So divide both sides by 3. So like get that k is 3. So my equation, it's always my second line with my value of k in. So that's my equation that I'm going to be using. Right, now I go to this bit. Find q when m equals 10. Right, I'm going to use my equation now. I don't care at all about the stuff in the pink circle anymore. That has served its purpose. That enabled me to find k, which enabled me to make my equation. And now I don't care about any of that. This is all that is important now. I'm finding q when m equals 10. So let's do that. So m equals 10. So whenever I see an m, I'm putting 10, and that equals 3q. Now you're all going to be thinking, your hands would be flying up. Decimals or fractions, we're going to work with fractions, okay? So I'm going to divide both sides by 3, and that's going to give me Q. So that would be my answer for Q. Okay? It's almost like this is kind of drawing your graph, and then this is when you use the graph. You know, when you go up and across and you see what the number would be. That's what we're doing here, but we're just doing it algebraically, and often we'll get nasty fractions. Okay? Right. Let's do one more, just a little bit different. Let's do one more. I say a little bit different. I mean, it really isn't, but let's just have a little look, and then I'll let you get on. So, A is directly proportional. Now, I think it is worth saying they won't always put directly in. Directly is implied. So if they say A is proportional to B, they mean A is directly proportional. If they want inverse proportion, which is what we'll do next time, they will always write inverse. So directly is kind of implied. But anyway, A is directly proportional to the square of B. When B equals 2, A equals 12, find A when B equals 10. Right, let us not panic. A is directly proportional to the square of B. Now that isn't the square root, that's the square of B. That's B squared. Now one word in here, if I'd put root in there, everything would change. I would have A fishy square root B, and then all my numbers would be different. So just read super, super carefully. So I've got A is directly proportional to the square of B. Now I could say B squared. That would be the same. Right, even though I've got a squared, I don't care. I'm going to the fish market. Trade my fish for an equals and a K. Right, let's stick the numbers in. When B equals 2, A equals 12. So I've put those numbers in. Now I need to work out K. So even though I've got a squared there, it doesn't matter because I'm working out K. So I'll probably work out 2 squared first, and then I'm going to divide by 4. Remember now, your equation is your second line with your value of K. So it's A equals 3B squared. Do not forget that squared. It's your second line with your K in. Right, so now let's use that equation. A equals 3B squared. So I'm trying to find A when B equals 10. Oh, and there'll be somebody that does 3 times 10 and then square it. Foolish error. 3 times 10 squared is 100. 3 times 100. So that would be my answer to the second part. Please get in touch if when you try the questions you get stuck, okay? I need you to keep in touch with me. I'd like you to do now worksheet, what are we up to this week? 3? Yeah, let's do worksheet 3. Okay, so please set every question out like that, okay? And get in touch if you're stuck.